All right, so lesson 6-3 is subtract linear expressions, okay? So the first thing I want you to do is write down this vocabulary. This is additive inverses of expressions. It says when two expressions have a sum of 0, the expressions are additive inverses. So remember when we did integers and we were talking about additive inverses, and we said 7 and -7 are additive inverses because if we add those together, we get 0. Well, the same thing is with expressions. If I have an expression and the additive inverse of that expression, if we add them together, those two expressions, we should end up with 0. So to find the additive inverse of an expression, we're going to use the distributive property to multiply that expression times a -1. Make sure you write down that sentence also. So here, for example, if we're going to find the additive inverse of 5x minus 7, you don't have to write this part down because we're going to write down some examples. 5x minus 7, we're going to use the distributive property here and multiply that expression times a -1. So when we distribute, we're going to multiply -1 times everything inside the parentheses. So -1 times 5x is -5x. And then -1 times -7 is +7. Negative times a negative is a positive. So this is the additive inverse. That's the additive inverse. So if we add those together, 5x minus 7 plus a -5x plus 7, if we add those together, let's see what happens. So we've got, there's my like terms. This is a plus negative, right? That's plus negative, that means minus, right? And then over here, we've got a -7 and a +7. So 5x plus a -5x, that's equal to 0. And -7 plus 7, that's equal to a 0. So if I add 0 plus 0, that's going to give me 0. So these do add up to 0. So these two expressions are additive inverses. Okay? These two expressions are additive inverses. So for example 1, we want to find the additive inverse of the expressions. So again, all you're going to do is use the distributive property to multiply times a -1. All right, so we want to multiply each of these terms times a -1. So that -1 gets distributed throughout the parentheses. So -1 times 3 is -3, and -1 times -7x is +7x. There is my additive inverse. Is that clear? Okay, so we want to do the same thing over here. We want to multiply times a -1. So that -1 times a -8x and a -1 times a +5. So -1 times -8x is +8x, and a -1 times a +5 is -5. And there is your additive inverse. All right, example 2 is again subtract linear expressions. It says, when subtracting integers, you add the opposite or the additive inverse. The same process is used when subtracting linear expressions. You can distribute the -1 or you can use the stack method. So here, you guys remember, when you have no number in front, that's going to be a 1 in front, right? On the second one, this says minus the quantity 3y plus 4. So minus when we do this, we're actually distributing a -1. So that's where we're going to get that additive inverse. So for the first one, we can just take the parentheses away. So we have 8y minus 5. And then we have to distribute this -1 throughout the parentheses. So that's going to be -1 times positive 3y is a negative 3y. And -1 times positive 4 is a negative 4. Okay? So when we use our shapes, we've got an 8y and a negative 3y. We've got a negative 5 and a negative 4. So here, 8y minus 3y is 5y, and negative 5 plus a negative 4 is a negative 9. Okay? Now, take a look at how it looks when we are using the stacking method. Okay? Now remember, when you are subtracting, you're going to keep, change, change. Right? Now, what are we keeping and what are we changing? So here, we're going to keep this expression, this first expression. We're going to change that subtraction to addition, and we're going to change everything inside this parentheses to the opposite of what it is. Okay? So here we have to rewrite. So we're going to keep 8y minus 5. Okay? Actually, I'm not going to rewrite. I'm just going to write on my problem. We're going to keep this first expression the same. So this 8y minus 5 stays the same. The subtraction becomes addition. I'm just going to use my colors. And everything inside the parentheses here becomes the opposite. So this was a positive 3y. That's going to become a negative 3y. This was a positive 4. This is going to become a negative 4. Is everybody with me? So now, here we have, when we do our stacking here, now we're adding. So we're going to follow the same steps we did in the last class. So negative 5 plus negative 4 is negative 9. And then here, 8y plus a negative 3y, that's going to be 5y. Does everybody see you get the same thing? Good. So here, and I'm sorry, this is supposed to say subtract. Subtract linear expressions. All right, so again, we have the two different methods. Okay, these are the shapes over here, and this is the stacking. Okay. Now, we're going to distribute that -1 throughout the parentheses. Okay. So, in this one, when we distribute this positive 1 out here, we can get that just means we can take away the parentheses. So this is going to be a negative 3x plus 9. And then over here we have a -1 times negative 7, which is a positive 7. And then -1 times a positive 8x is a negative 8x. Very good. On this side, we're going to keep, change, change. Right? So that first expression stays the same. The subtraction becomes addition, and everything inside the parentheses becomes the opposite. So the -7, oh, look what's happening here. Can I leave this like that? Are those the same? Ooh-wee, good catch, good catch. We have to rearrange this so that like terms are in the same column. Does everybody see that? So here we want to move, let's move this 8x to the first column. Okay. And then that's going to be a positive. Good. Okay, and then this is going to be minus 7 because that's a negative 7. So now we're better. So now we can keep, change. Is everybody clear? So that was a good catch. We need to make sure that we have all of our like terms in the same column. Okay. So we're going to keep the first expression. Then subtraction becomes addition. And everything inside the parentheses becomes the opposite. So this positive 8x becomes a negative 8x. And this negative 7 becomes a positive 7. Very good. So now we can add. So we've got 9 plus 7. That's going to give us 16. Positive, right? Positive 16. And then we've got a negative 3x plus a negative 8. That is a negative 11x. And then showing the shapes over here, we've got our negative 3x and our negative 8x. And we have our positive 9 and our positive 7. So negative 3x minus 8x, that's negative 11x. And then positive 9 plus 7 is a positive 16. And so you can see you can get this, you'll get the same thing either method. All right, so here with the first expression, we can just take away the parentheses because that is a positive 1. Over here, this is a negative 1, and we want to distribute that negative 1 throughout the parentheses. So here, negative 1 times negative 5x is a positive 5x. And negative 1 times negative 2 is a positive 2. When I combine my like terms, I've got negative 4x plus 5x, that is a positive 1x, or just x. And then we've got negative 7 plus 2, that's a negative 5. Now, if you did the stacking method, you're going to keep, change. So you keep the first expression, the subtraction becomes addition, and everything inside this parentheses becomes the opposite. So that negative 5x becomes a positive 5x. This negative 2 becomes a positive 2. And now we've got negative 7 plus 2, that's negative 5. And negative 4x plus a positive 5x, that's x. And we get the same thing. So example 3 is subtracting linear expressions. And it says here, you don't have to write it down, the process is the same when subtracting expressions involving rational numbers. We're still going to combine our like terms. We're still going to distribute this negative 1 throughout the parentheses. Okay? So here, we're going to, we have a 1 in front of here, and we have a negative 1 in front of there. So the first one, we can just take away the parentheses. So that's going to be 3/4 minus 1/6 x. Okay? And then over here, we've got, we're going to distribute that negative 1 throughout the parentheses. So that's negative 1 times a negative 1/8. That's a positive 1/8. And then here, negative 1 times a positive 1/2 x is a negative 1/2 x. Is everybody clear with that? Okay, so if you're doing your stacking, let's see, I'm going to put, actually, look, I can do it the way it is. So we've got 3/4 minus 1/6 x minus, hold on, negative 1/8 plus 1/2 x. Now, does everybody see that I put the x terms last? I put the constants first? Yes. It is okay to do that. I'll just write my final answer in the correct order, okay? So now, before we start, of course, we need to get common denominators, right? So we've got a negative 1/6 x over here, and we've got a negative 1/2 x over there. We've got a positive 3/4 over here, and a positive 1/8 over here. So, with our like terms, the common denominator with the 6 and the 2 is 6. So we're going to multiply times 3 here and here. And the common denominator with 4 and 8 is 8. So we're going to multiply times 2 times 2. So I'm going to rewrite. So we've got 6/8 minus 1/6 plus 1/8. And then this one's going to say minus 3/6 x. So now we can combine our like terms, right? So we've got, let's see, the x terms first. So negative 1/6 x plus a negative 3/6 is negative 4/6 x. And then we've got a positive 6/8 plus 1/8 is, so plus 7/8. Now, of course, does everybody see this 4/6 right here? Yes, we can simplify that by dividing by 2. So we'll divide this by 2 and divide this by 2. And I'm going to write it over here because I don't have any space. So this is going to be equal to negative 2/3 x plus 7/8. Is everybody clear? All right, so for example 3, we're going to use this distributive property method. So we're going to, when we distribute a positive 1, of course, nothing changes, so we can just rewrite. So we have 3/4 minus 1/6 x, okay? And now we want to distribute that negative 1 throughout the parentheses. So negative times a negative is a positive. So this is going to be plus 1/8. And then this negative times a positive is a negative. So this one is going to be a negative 1/2 x. Okay? So now, if we're looking at our like terms, okay, we've got a negative 1/6 x and a negative 1/2 x. We also have a positive 3/4 and a positive 1/8. So before we can add these together, we need to have common denominators, right? So here, I'm going to look at the x terms. So we've got 6 and 2. What's the common denominator with 6 and 2? 6. So we're going to multiply times 3 here and times 3 there. And with 4 and 8, the common denominator is 8. So we're going to multiply times 2 here and times 2 there. And so now I can rewrite. So this is going to be 6/8 minus 1/6 x plus 1/8 minus 3/6 x. So our like terms are right there again. And now we can combine. So negative 1/6 x plus a negative 3/6 x is equal to a negative 4/6 x. And then 6/8 plus 1/8 is positive 7/8. And of course, you guys, we've got this 4/6, which we can simplify by dividing by 2. Very good. Divide by 2. And I'm going to write it over here because I don't have any space. So this is going to be a negative 2/3 x plus 7/8. All right, so here, you guys, we have a negative 3/5 x minus 1/8 minus 1/3 x minus 3/4. Okay? Now, with our like terms, you see we have the x terms and we have the constants. We have to get common denominators, right? So let's rewrite our common denominators. Now, we've got a 3/5 x and a 1/3 x. What's the common denominator with 5 and 3? 15. So we want to multiply times 3 times 3, and then over here we're going to multiply times 5 times 5. With 8 and 4, the common denominator is 8. So we're going to multiply times 2 times 2. Is everybody with me? Now, I'm going to go ahead and rewrite before I do my distributive property. Okay? So we've got 9/15 x minus 1/8, rewrite, minus, this is going to be 5/15 x, and then minus 6/8. Everybody with me so far? Huh? Yes. So now we distribute. Okay, so we'll distribute the -1 through on this side, and this side we can just take away the parentheses. So that's going to be 9/15 x minus 1/8. And then over here we have a -1 times a positive 5/15 x. That's going to be a negative 5/15 x. And then over here we have a -1 times a negative 6/8. That's going to be a positive 6/8. And now we can combine our like terms. So we've got a 9/15 x and a negative 5/15 x. We've got a negative 1/8 and a positive 6/8. So 9/15 x minus 5/15 x is, what's 9 minus 5? 4. So this is going to be 4/15 x. And then we've got a negative 1/8 plus 6/8. What's that? What's -1 plus 6? Positive 5. Remember, you subtract the digits and take the sign of the bigger digit. So this is going to be plus 5/8. And that's the end of it. So Bonnie owns a t-shirt shop where she sells plain t-shirts and printed t-shirts. The table shows the cost per shirt and the number of each type of shirt sold over W weeks. After 12 weeks, how much more did she earn in sales of printed t-shirts than in sales of plain t-shirts? Okay? So what is the important information here? Right. So here are the important expressions, okay? There's plain t-shirts and printed t-shirts, okay? And we want to know how much more did she earn in sales of printed t-shirts than plain t-shirts. So that means she earned more for the printed t-shirts, right? So that means we're going to subtract printed minus plain. Is everybody clear with that? Okay. So we write our expression. So we've got the printed is 8W plus 3 minus 5W minus 4. So the first thing we want to do is our distributive property, okay? So when we distribute a positive 1, that means we can just take away those parentheses because nothing changes. So that's 8W plus 3. And then we have negative 1 times positive 5W. That's a negative 5W. And then we've got a negative 1 times a negative 4. That's a negative times a negative is a positive. Very good. So now we can combine our like terms. So we have an 8W here and a negative 5W there. We've got a positive 3 here and a positive 4 there. And now we just subtract. So 8W are combined. 8W minus 5W is 3W, right? And then positive 3 plus 4 is 7. So this is the expression that will tell us how much more she earned, right? After 25 weeks, how much more did she earn in sales of printed t-shirts than in sales of plain t-shirts? So this is the expression. Is it going to give us that answer, right? How do I get my answer? Very good. We have to evaluate when W is equal to 15. So we're going to substitute 15 in for W. So we've got 3 times 15 plus 7. So 3 times 15, of course, is 45. Plus 7 is 52. So she earned $52 more selling printed t-shirts.